stuff. Okay, waking up is really fun. I enjoy that. I enjoy mornings. Goddamn. Alright. Hello, what's up? Getting later each day. That's okay, I suppose. Whatever. Okay, let's do something. What was this one? Alright, this was 3,500. Yeah. This one is also 3,500. What was this one? That one's boring. This one we've solved A to D. Okay, sure. I guess we should do this one. Let's define the function f of multiset A as a multiset of number of occurrences of every number. Numbers of size no more than n. Let's define the function f of multiset A as the multiset of number of occurrences of every number as present in A. Number of occurrences of every number that is present in A. E.g. f of 5, 5, 1, 2, 5, 2, 3, 3, 9, 5. Given integers n, k, you're asked how many different values the function can have. For A is an arbitrary non-empty array with numbers of size no more than n. Print the answer mod. So, I mean, the answer is going to shrink really fast. I got this step one, it's a frequency array. So we're counting how many distinct frequency arrays there are, which is the number of partitions. After step two, we have a bunch of numbers that sum to n. We're counting the frequency arrays of those. What time is it here? It's 1:50 p.m. I've never had a good sleep schedule. Yes, indeed. Yeah, I've been sleep solving problems, sure. No, I've had weird dreams. My dreams have become enticing. Like, I don't want to wake up because I want to continue my dream. That's why I'm not waking up. It's weird. It's very I've never actually experienced that before. It's weird. It's too much effort to have a camera. Like, it's gonna make me a lot more tired throughout. I don't really care about views. I'm doing this for myself. So after step one, we have an array that sums to n. We have an array that sums to up to n. So we have an array that sums to less than or equal to n. After step 2, the length is at most a root n. This seems annoying. After step 2, the length is at most root n. And the numbers themselves. Okay, so we have a bunch of partitions of length n. So in step 1, right, you have to sum to at most n. You have a bunch of numbers that sum to at most n. In step 2, we're taking the frequency array of a bunch of numbers that sum to at most n. Like when I did contest 3 years ago, a lot better. At least like 200 rating, I would hope. Okay, this is not the most in it right now, but I need to wake up and do this. So after step 2, how do we do this without hard coding it? That is my question. I mean, it's not like after 3, after 3 the answer is pretty small, I would say. But like how small? So we have a frequency array of frequency arrays. Right? So we have a frequency array of sets that sum to at most n. So like the first number is at most n. The second number is at most n over 2. The third number is at most, etc. The number of distinct numbers is at most root n. And we don't have that many values. We don't have that many values. Like past a very small point we can enumerate. That's the thing. Past a very small point we can enumerate. past what point? All right, so for step 3, we have frequency arrays of numbers with sum at most n. So we consider the partitions. And the number of partitions is huge. After we place down the ones, then we don't have that many possible arrays. F of multiset A is the number of occurrences of every number that is present in A. So the biggest value a number can have is root n. We have at most root n elements. Or root 2n. No, wait. We have at most root 2n elements in F2. Which is small, right? Square root of 4,000. Yeah. We count the ones, right? And each 2 is going to cost us twice as much. So we can directly count the 1s and the 2s, right? Can we? Wait. Well, we can easily count the 1s. Then to count the 2s, right? Okay, I see. So what we need to do then is enumerate the elements. So for size 1, every element has cost 1. For size 2, each element has a cost. what is the cost? So to have a 5, right? To have a 5 in f of 2, that means you're going to drag, let's say this 5 is going to take from the 1s. Each such 1 has cost 2. And if we have a 4, you're going to take from the 2s. Each such 2 has cost 2. Okay. And in array 2, we have costed most small. Okay, I can see this coming together. How am I? Tired. Very tired. Ugh. We're doing hello eventually. Not this week, probably. Probably not next week, I suppose. What is the most effective way to practice for IOI? Do OI problems, I suppose. Probably. That's probably the biggest thing. OI is more knowledge-oriented, so review the syllabus, make sure you know everything, make sure you're prepared for everything. But I mean, do problems in the thing you're trying to get good at is the general move. Okay, so the second one, yeah. For the third one, so if we're going to place down a 5, then we're going to assume this 5 is going to be with these 1s. So the cost of some 1. plus the sum 1. Right. So if we take in this many elements, right? This means how does this work? So it means we have this array. Our previous element was x. Means we've taken some so the first thing always has cost 1. To take a second one, it means taking a single 2 from here. Which is exponential. Which means we're going to take 2's from here. Which means we're going to take Is it iterated prefix sums? It is, right? It's iterated prefix sums. So to take a single element, so we have this mod. So to take the first one, this is fine. So to take, to take a 1 from here. So if we're building 2, right? To take the first one, that means to take a 1. To take the second one, that means you're going to be from 2. Wait, to take the second element, right? This is so weird. This is so weird. To take the second element, everything's going to correspond to a distinct sequence, so that's fine. Okay, so to take the first element, right? If we're going to take a 5, that means we need to pull from 1s. So everything in U has cost 1. If we take a 50, right? And that means we're going to take yes. Take 52s. If we take a 5, and then we take another 5, right? And this 5 is going to be made up of 2s from this array. Each 2 is going to represent wait, I'm so confused. I'm so confused. Like pulling from costs, you take a 50 and take a 5, right? It means you're going to pull from this many 1s. Right, okay. For the second array, taking a 5 has cost 1 regardless of position. Because each of you has cost 1. Having a 2 in here I'm seeing it. Taking this many 2s from here. Right, then when we get to depth 3, right, then it gets more complicated. Because the first one is just that's fine. First one can be made up of just 1s. The second one we take, right, has to be from a 2 in here. If we take a second one, that has to be from a 2 in here. And cost 2 in here depends. If we take a 2, right, then that has to be from, like, say, 5s in here. We take a second one in here. Well, we're considering compressing twice, aren't we? Well, what are we doing? I mean, yeah, we're considering compressing twice. We are considering compressing twice. And the length is harmonic. And it's tiny. I'm very confused. I'm very, very, very... It's hard to wrap my mind around. Okay, so we're at depth 3. We take a 1. Yeah. And if we take another 1, then this is going to be 2, right? Then we're taking a second 1 here. Which doesn't cost 1 anymore. It's the cost of... We're assuming you're going to be a 2 from the second array. Do we need to go 3 back? I'm actually so confused. We're taking cost 1. And we need to take cost 2. I'm taking a 1. Right. Taking a 5, then we're taking 5 1s. 5 1s is going to correspond to 1, 2, 3, 4, 5. 2 back. One, 2, 3, 4, 5 is going to correspond to 1, 2, 2, 3, 3, 3, 4, 4, 4, 4, 5, 5, 5, 5, 5, 5 back, 4 back, 3 back. Going to correspond to 5 1s, which is going to correspond to 1, 2, 3, 4, 5 here. Like, we need to keep track of multiple things. Right, so I place down a 5. We're going to cost 5 1s. I place down a 2. We're going to cost 2 2s. We're going to cost 2 2s. Second 1 is going to be a 2. So knowing that we're taking the first 1 from all of these layers. The second 1 is thus going to be a 2 from here. Which is thus going to be 2 2s from here. Which is thus going to be 2 2s. Now we're noting that we're taking this. So we're going to take 1 2 from here. Can we represent this cost like nice? we're going to take 1, 2 from here. So if we're going to put a 2 here, we're going to take 1, 1 from here. Which is going to be 1, 2 from here. It's going to be 1, 2, 2 from here. It's going to be 1, 2, 2, 3, 3 from here. This is going to be a lot. It's going to be a lot. Okay, so the cost is not a nice function. Because it depends on all this previous stuff. So we do 1, 1, right? You're going to turn into 1, 2. If we do 2, you're going to turn into 1, 1. How do we do this? So on the first array, right? You can have all the 1s. In the second array, we can have all the 2s. In the second array, we can have to 68 ones. Let's say 10, right? So we can have 10 ones from the first array. Let's say 30, right? So we can have 30 ones from the first array. 29 twos. Down to 130. I don't know how we do the cost nicely. Because, I mean, the cost even depends on the previous states, right? Like we could have a 5, and then we could have a 2. And that's going to represent 5 ones. And 2 twos here. Linear. I have an n because the cost of having u is linear. Cost of having u is quadratic. Cost of having u is probably cubic. You just need to make u work. You can't have too many things. What in the world? assuming we don't have to worry about this. What makes you afraid? Shouldn't the fact that someone solved it quickly like make it seem easier? So you're going to be cubic. It's like the biggest such number of you can be 68. And then we can have like almost 30 distinct elements. Which means that the number of arrays is really small. For 2, you're kind of big. For 3, you're pretty small. For 4, you're going to be tiny, right? Like for 4, we have a 5. You're going to translate into 5 ones. It's going to translate into 1, 2, 3, 4, 5. It's going to translate into 1. Yeah. So we have a 5 at depth 4. I'm going to translate into 5 ones at depth 3. It's going to translate into 1, 2, 3, 4, 5 at depth 2. It's going to translate into a sum of squares at depth. Yeah. So if we have a 2, 5 at depth 4. Let's say 1, 1, right? You're going to translate into 2, 1. You're going to be this many 2s. This means you're gonna be pretty big. It's like, how does this work, man? If we're gonna have like a 10, right? You're gonna be ones. And you're gonna be up to 10. And you're gonna be up to 10 squared. So it's gonna be the sum of squares. We have a 10 to 10. We're gonna have 10 ones and 10 twos. We're gonna have 10 ones and 10 twos. Which means we're gonna have 1 to 10, and then 2 of each of 11 to 20. Then 1's gonna be 1. Two of each of 11 to 20. And then 1 will be 1. 2 will translate into 2 twos. All right, and just those 20s alone, right? That's going to translate into 20 30s. So the second element can't be bigger than 10. Which, like, you know, that's pretty telling. If we have an array of length 10, right, then that translates to 1 to 10 and cost 2. It translates to 1 to 10 and cost 2. And cost 3. Which translates to a lot. Yeah. Okay, so vector pair LLVO 0. Wait, what are we doing? All right. Okay, right. Oh, VI. $139. Yes, okay. Good. Now map LLC. So So depth is 2. Yeah. Okay. Are you serious? C is greater than n, return. Okay, that's better. What? Why? Oh, it should be somewhat faster, right? Damn. Okay, is greater than 2. C is greater than n, return 1. Vector pair LLV. Let's do that. Yeah, because that's going to be like the biggest part. Really? Oh, wait. Else break. That should make life easier. Beautiful. Wait, really? Wait. Holy Christ. Okay, cool. This problem is so dumb. I did not solve wise, man. I don't know how to do that, man. It's freaking hard. Okay. Explain what? This? What's going on here? What's going on here is this problem is stupid. For most of this, oh my god. That for k bigger than 2, the stuff is tiny. So, k greater than or equal to 3. For k being too big, there are not many arrays. And for k being too small, we can just do it naively. Okay, how do we do, or not naively, but like, yeah, like pretty much naively. How do we do 2? Else if k is equal to 2, solve 1. So solve 1 is easy. We do it with dp. More interesting part is solve 2. How how would solve 2 work? So we know that solve 2. Okay, wait. Can I make LL equals long one? And still have you pass? I can, right? Good. Let's make sure you work. Yes. Okay. So how does solve 2 work? So we're going to iterate over the largest element. To take a 5, you're going to be 5 ones. Okay, sure. All right, so how much memory do you get? Okay. M plus 1. So I'm not using K. Okay. We're gonna need PS. So dp0 0 is equal to 1. PS equal to PS plus dpij. I plus j, j. PS mod mod. VO right? What? Okay. Sure. Okay. So now we need to do solve 2. Which is kind of a pain. Oh. So we had this DP array where the previous thing was this. Okay, so vector cost 0, previous n is equal to 1. Plus. Okay, this is an overestimate, but that's fine. So for S0 is less equal to n s plus plus. DPS PV mod mod. V. If NDP S plus V times I V vector VLDP n plus 1 VL n plus 1. is greater than or equal to 0, v minus minus. PS is PS plus dps v. Oh, wait. Otherwise, we're gonna. Yes. Okay. Good. 32. What? Why? Vector VL dp n plus 1 VL n plus 1. dp 0 n is 1. It's a 0. For I is 1, I is less than or equal to min 70 LL n. Vector VL n dp n plus 1 VL n over I plus 1. For LS is 0 up to n. V is dps dot size. Place down value v. So, is this true? Wait. Right? If we're going to place down a 2 here, at this position, if we're going to place down a 2 at position 5, that means we need to take 2 5s, which has cost 10. S plus V times I, V. OV is dps dot size. Something like this. The hell? What? We're going out of bounds. Vector VL dp n plus 1 VL n plus 1. dp 0 n is 1. For I is 1. For LOV is dps dot size. Greater than 0, v minus minus. PS is PS plus dp s. Oh my god. There we go. Okay. Make sure you all run in time. 62 milliseconds. Okay, beautiful. Nice. Wow, that was instant. What the hell? Why was that so instant? It's a lot of tests. This problem. I don't know what to say about it. It's just kind of dumb. It's a lot of tests. That's so many tests. Okay, well, that was a thing. Is F solvable? I assume not, right? Oh, look at it. No. Okay. Okay. Okay, yeah. Nah. Yeah, no. Okay. Which one was this one? We did this one, right? Count exercises, some flow problem. Do you have solves? Not really. You're kind of impossible. You're also kind of impossible. This one... This one, yeah, this one's dumb. I remember this round. We've got to find a problem we can do. We looked at F. How hard is H? Pretty hard. It's like 34. We need to do that. Don't want to do this one. How's G here? See, the problem is, okay, going through this is hard because I've already done this. I've already like looked at these. We'll see what we can do with these, and then if not, we'll find another way to find problems, I guess. Finish this one? Yeah, this one, right. I guess we ought to do this one. I remember this one's annoying, but we'll look at it, I suppose. I don't know if it's annoying. I thought it was annoying. It doesn't necessarily mean it's annoying. Of course, this was knocking on the door, and our protagonist Bob was preparing a spectacular present for his longtime second best friend Charlie. Bob's tree can be represented as, yeah. First, he listed the n-1 edges in some order, then he considered the edges one by one in that order. For each edge UV, he swapped the decorations of node U with the one of node V. Bobo. Right. Fortunately, no decorations were lost, so Bob could prepare the tree in no time. they listed the n-1 edges in some order, right? So how does this work? So we have a certain number of paths. If any paths intersect via edges, then nothing will happen. Then it's impossible. If any node ends up at itself or any path intersects via edges, then it's impossible. We have 1E9 mod, which means the FFT thing we did before is not going to work. So, yeah, if any path intersects via edges, then that's bad. We can bring any of you over. Then you can be moved here. There's some other problem I solved that was like this, and it was something else. It was different. You can think about it in reverse. Well, wait, now, paths can intersect via edges, right? We're going to have two things being swapped. Paths can intersect via edges. What does that mean? What does that imply? is this working on? So if we pick some configuration, what do we need for it to be possible? What do we need for a sub-configuration to be possible? Two paths intersect by more than one edge. That won't work. If I need to go to U, right? Okay, let's think about this DP like, right? So we're noting that every edge must be swapped, not just some edges, which makes this problem different. Every node is going to have some node from its subtree. Every node is going to have some node from its subtree. Some node from one of its... Yeah. But what marks an impossible configuration? So some edge needs to get used more than twice, then that's problematic. So I mean, we add the directed paths to the tree, right? If some node needs to stay on itself, then we're screwed. If some node, if there is some edge such that two paths need to go along that edge in the same direction, then we're screwed. If there's some edge such that two paths need to go along that edge in a different direction, and we drag that up there, swap you, and then finish it. So consider some edge. Consider the paths that go through this edge. Oh, right. Okay, that's why this doesn't need FFT, because we're taking all of them, not just subsets. Okay, yes, I see. So we're considering the tree DP to do without this stuff, right? So we consider some node, we consider its subtree. We consider the order of edges incident to it. What? What's that? So consider the tree DP. So we can order you however we want. Oh. Wait, how does this work? We consider the tree DP that lets you do this. do you here? Let me order the children. Let me order the parent. Alright, so it's degree factorial, right? That's what we're doing here. Scene to n. Vector PL EL. Cn to x to y. Why am I doing that here? EL, they'll push back x, y. VLAN. Push back. Okay. VLA. We have 129 mod. DN. What? Okay. Okay. Yes. Okay, now so what does this mean? Here we put some constraints on what can be done for each vertex. So considering some node and considering its incident edges, the edge that uses this, if an edge sends if an edge sends a value to this node, then it must be last. If an edge So we consider the constraints that it puts on the edges, or consider the constraints that it puts on this node. So basically every node is independent. Regardless of whatever the hell happens here, we're going to get something from here. Yeah. So if we have to get this from this, then you're going to be last. If we have a multi-directional edge, if something uses the first one, then it must be first. And if we have chains, then it means these have to be together. If you have chains, then it means these have to be together. So this isn't really DP. We're looking at the edges objectively. And we're looking at how we permute these edges. So if we have like a 4-2, we're assuming that you're going to be from here, because otherwise, like, this makes no sense. Yeah, we're assuming you're going to be from here. If an edge has multiple load, we screw it. If an edge has, If an edge has multiple load, we screw it. If an edge has stuff, we screw it. So if we send something in here, then we do this, then it means you must be together. If we send something in here, then we don't need it anywhere. Well, no, if we send something in here, we're going to need it somewhere. So either you're going to attach to the end or you're going to attach to some other. So either you're going to attach this to the end or you're going to attach two edges together. Similarly, we're going to attach this to the beginning, where we're going to attach two edges together. So, thinking this through, since we have that 4 must end up in 2, you're going to attach this to the end. I'm starting to see this. So we look at the edges. For every distinct thing, okay, well, I mean, this isn't over yet. This isn't over yet. So I have a constraint that says this must be right after this. So if we exchange a 6, 5, right? If we exchange a 6, 5, then this puts a constraint on this that says, well, we send a 6 up here, then we send a 6 up here. So that means this edge must be right after this edge. Then we send a 6, then we send a 5 up here, and we send a 5 up here, and that says this edge must be right after this edge, which is just clearly not possible. So we look at each node, we look at the edges incident to it, and we try and construct a valid ordering. Since each node is independent, if we accomplish that for each node, then we succeed, right? And that's it. If we accomplish that for each node, we succeed. How do we check this? How do we check this? How do we validate this? All right, so if we send you to this, yeah, so we look at each incoming. It's guaranteed that no label appears more than once. Okay, so if you're incoming, then you must be at the start. If you're outgoing, then this must be at the end. It seems fine to just do this. It seems fine to just do this, right? So we have like this next array. And we have -1 in n, right? And so we're going to say, okay, so if you have exactly 1, the next -1 is here. If you have exactly n, then we pull from something with n degree 0. Okay, yes. Okay. I'm seeing this. Okay, so we're never going to need to send one node in more than one direction. How do we keep track of outgoing? This is a little bit of a pain, but I think it's fine. So we do LCA. Still need mod op. Else. No. For RNG mod 3 is equal to 0. P is equal to 0. While VP is not equal to -1. Okay. All right, now okay. PL norm. Map PL map LU. Sorry. Okay, so for if vi is not equal to -1, LCA dot depth L is less than LCA dot depth X. PLR norm LX. Auto V is MP R. So we're sending from X. MPRX. If V dot size is greater than or equal to 1, turn. Return 0. Okay. V dot push back T dot push back VI. X equal to LCA dot lift X 0. While LCA dot depth X is less than LCA dot depth I. No, wait. P. Yeah. P is LCA dot lift get I LCA dot depth I minus LCA dot depth X minus 1. PLR norm PX. Okay. Let's just do while X is not equal to L. While X is not equal to I. 4 Okay, we're gonna do it this way. So it's gonna be atrocious and log n, but that's fine. You have 4 seconds, right? Yeah. Okay, so LLAnts is 1. For I 0 up to n. Map LL next. For LX edge I, PLR is norm xi. T dot size is greater than or equal to 1. Return 0. For LLY MP. So for everything outgoing, so we're never going to have x go out and x go in. No, wait, what am I saying? Yeah. So for LLX, MP, R, I. Map. So for LX, MP, R, I. For LY, 2x dot for LLY MPRI. So for each thing outgoing from I, for each thing that must go out from I, 2x dot s is equal to 2x dot s is equal to, no, it's 2y dot s is equal to x. X 2y dot f is equal to x. X p 2. If x is equal to I, So if x is equal to I, next 0. If s is not equal to 0, then this is incoming here. So this must be last. Next, s is equal to n plus 1. If t is not equal to 0, and this is outgoing, so this is outgoing, so this is the second, which means this is outgoing from I, which means that you must be first. So next 0 is equal to t. Else next s is equal to t. For x edge I, st dot insert. X plus 1. So we don't need you. We're just gonna get rid of you anyway. So we need the next dot size plus s dot size for that's not enough. Okay, so VL ord. Word dot push back y. While next dot count y. Ooh, can is equal to 1. So map so if ord dot size or.size is not equal to add I.size plus 2, answers 0, break. For auto x, if pause x plus 1 is not equal to pause y, and it's 0, then return 0. Return 0. Ants equal to ants times fact s mod mod. Okay. Right. R0. No, wait, how's this work? So if you go all the way to the end, that's fine. If we have one gap or 0 gaps, if we have one gap or 0 gaps, R is 12. Okay, we're not. What the hell? Next. Alright, what is going on? So, PRMP, right? What? If VI is not equal to -1. What? X is 3. I is 1. I didn't. Let's see. Yes. R is 2. This should actually break. No. Yeah, okay. Sure. if vi is equal to -1, or vi PR count cool. Damn, okay. Be that way. RNG. Oh, that's problematic. You don't even make it to MP. Cause, okay, MP.clear. Yeah, that would matter. Okay, I guess you passed. Oh no, okay. Alright, good to know. Let's make you smaller, right? So resetting LCA or clearing map. Yeah. PR. So 5, 1, 2, 1, 3, 3, 4, 3, 5. Okay. Yes, I mean I can visualize what this looks like, but okay. So we want 3 and 4. So we want 3 to go to 1. No, we want 4 to go to 1. And this to go here. So why is this invalid? I is 3, agi is 2. We're failing here. Agi is 2. 4 must go here. And then this must go out. So we're getting a demand for this to leave here. Wait, what are we doing? Oh, if t is not equal to 0, so if x is I, right? Then we're sending you out. So you're going to be second. So if s is not equal to 0, return 0. So if we're not sending you out, so for each thing in x, right, we're going to get you from here. And when we send you out, so if t is equal to -1, t is equal to n plus 1. That's what we're doing. Okay, that's convenient. If s is not equal to 0, bro. If local. Make life easier for yourself. Okay. So we need 1. So we need 1 to go to 0 and 3 to go to 1. Okay. What? Oh, right. So we need 1 to go to 0 and 3 to go to 1. Wait, why can't we do this? One to go to 0 and 3 to go to 1. There are not many interesting trees of size 5. 1 to go to here, 2 to go to 1. Why is this not possible? So if we swap 2, 0, we need 1 to go to 0. Oh, right. Okay. So then, what happens at this? Right. If pause wait, okay. Here's what we need to do. So all of v is 0. While next.count v is equal to next v. If v is equal to n plus 1 and okay, beautiful. Now we can get rid of all these prints. Okay, sure. This equals ants times fact s mod. Cool. Should print the answer. Enough. And we have 29 mod. Yes. Okay, cool. Cool beans. So we could TLE, but I hope not. Because our constant is atrocious n log n. But I hope not. Yeah, okay, fine. This is dumb. Let me... God damn it. Our constant is so bad. It's actually crazy how bad the constant is. Okay, run is 0. N is 500,000. It's actually insane how bad the constant is. Oh my god. What? Wait. RNG mod 1 is equal to 0. Let's try this. X is equal to I. While X is not equal to L. LCA dot lift X 0. PLR is norm PX. Auto T is MPRX. MPRP. LP is LCA dot lift X 0. PLR is norm PX. Okay. Okay, sure. That should make life slightly easier. Map LL next. T dot insert X plus 1. For LOY ST or dot push back Y. Well, next dot count Y. Alright, you can get rid of like this stuff. For LX ST pause X is -1. Okay, sure. Just make the constant faster, right? Auto T is MPRP. T dot size is greater than or equal to 1. Should make life easier. If I get TLE again, this might actually be a... Damn. Is this an asymptotic issue? I mean, it shouldn't be, right? Huh. Modular 10 to the 9th plus 7. What the hell? Wait, what in the world? So we need you to be possible. I can't tell if you're a constant issue or not. Okay. Iota, VDOP again, VDOP. Shuffle, EL dot begin, EL dot end. Okay, this should work. RNG. $28.54. I feel like it's a constant issue. Holy crap. Okay. What in the world? Where? Why 500,000? Okay, I mean, this is probably not the issue, right? Map LO next. Okay, so BL spec. Okay, wait, this is, stop saving. Okay, right, so BL spec dot push back 0. For on next.
For Lx spec, this x is equal to 0. Next x is equal to -1. 2x is equal to 0, 0. For Lx spec 2x. St for Lx spec, if not this x, not this x, st dot push back x. Next y. Next y is not equal to -1. Okay, decompile. Okay. Show me. What? Cannot convert LL a spec. LX spec. LY is next x. If y is equal to -1, continue. Why do you compile locally? Okay. Why? Okay, VL spec. PLR is norm XY. For LYSI, 2y.s. LX spec. Auto ST is 2x. Anyway, spec dot push back I. Okay, so x is not equal to I. What? Okay. Why easier? So VL spec dot pushback x plus 1. Oh. For LX spec 2. Okay. Why? Why? Spec 2. What? Oh. That's why. Spec 2. I agi ord. LX spec 2. PRI 0, PRI. You know, make it here. Oh. Damn. Okay. Damn. Okay. Why? Why do I have to speed you up, man? Four, 1. Agi is 4. What? What in the world? Alright, we're gonna have to freaking debug with n equals 5 again. How? Okay, so this part's correct because we tested this. That makes sense. What are you? For LOYSI. Oh, crap. Okay, so spec is useless. Take dot push back y. Sign dot push back y1, that's plus 1. Two x dot s equal to y. Okay, good. All right, let's see how you run now. Boom mode is 1. Really? How? You don't have all the maps anymore, so you're probably faster at least.
Okay, good. Cool. Alright, that was fun. Finally solved the problem. Let's go. Okay, I want to do a virtual because I missed it yesterday. And that's cool. I haven't looked at chat in a while, sorry. I will look at that now. What's my minor? I don't have one. A lot of people do math minor in my position, but I kind of don't feel like it. I'm doing some math classes for fun, but I don't really see a point. Making a AAA game, yeah, sure. What do you mean? What do you mean if there are no mod ops? Look at this. Look at this. Look how big the answer gets. Look how big the freaking answer gets. Look at test 17. All right. Look how big the answer gets. What what do you mean? What do you mean, man? I mean no mod ops. CPH helper. I haven't tried it. I'm sure it's useful, but I'm fine with my setup. Virtual every day, I hope. I didn't do one yesterday because I spent the entire time dying, but that's the intent. It would be faster. It just it just wouldn't make it past test. What? Which test would it fail on? What's the first test it would fail on? Test 9, test 6. It wouldn't make it past test 6. That's where we're at. That's not very good, Kevin. Wrong answer on test 6 is not very good. Actually, the mod up is like nothing. Like it would be like 2 milliseconds faster because it's only doing this and then gen factorial actually, so it's not that bad. Okay. Cool. I don't know why I have to speed up my code for a problem with intended complexity, but whatever, I guess. That's cool. Freaking 500,000. How bad were you? So that's another div 1 finished. Nice. How bad were you before? Like, how bad was this? Before we linearized everything. 1934. Yeah, I don't know. This must have been just a particularly bad test. Oh, right, because all of these were being triggered. So this would be like maxed out, I guess. This all the STL stuff was being triggered. All right, I'll be right back. Then we'll start the virtual.
Here we are. Man. It feels nice to solve something. 1 second. Let me respond to something. Okay, cool. It would be faster. Okay. Let's do something. Div 2. Looked at this one. Somehow we decided not to, we decided not to do this one. This one's rebranding. Okay. This one. Flexible string. Okay, sure. Let's, holy crap. 500 lines. I write a lot of code. Actually, a lot of that is LCA, but still. That's a lot of code. A lot of code for one problem. I end up doing that with the hard ones just because debugging on stress is really nice. Debugging on stress is very, very nice. Okay, OBS is good. Terminal. We're going to do this. Okay. All right, we shall have fun. Having fun is mandatory. Anything unstressed? Wait, what do you mean? Wait, what do you mean? I'm talking about stress tests. Like, no, like debugging with like a stress test, which just means you get the test case automatically and you don't really have to think, which is nice. I'm not saying like stressed. Debugging while not stressed is also a good idea, I would say, yeah. Okay, cool. Let's do this. Yeah, no, I get that. No, stress tests are good. Interest rate there is 0. Ugh, why? Man, okay. Yeah, count 5. For x, a, c, and x, s plus equals x. For I is 1, I is not size, I plus plus. Plus plus count ai plus ai minus 1 plus. If count I s minus equals I, s plus equals 4 minus I, break. Three, negative 2, 4. Okay. So if that's the only possibility, sure. We're missing a case. 1, 2, 1, negative 1. Yeah, sure. BL count 5, C into N, BL N. Yes. Okay. Cool. Strange problem. Forbidden permutation. Given a permutation. What is the array A? It can be shown that there is always a sequence of moves so that the array A becomes good. In one move, you can swap two adjacent elements of the permutation P. Oh, for all. For all. Okay. If okay. Okay, that's okay. That's okay. If it was for any, that would be a bit problematic. For Li 0 I is less than N. C and AI minus AI, pause AI is equal to I. BM. I is 1, I is less than M, I plus plus. BI minus 1, Y is equal to BI. So, D is equal to pause Y minus pause X plus 1. Ants is min, ants max 0 LO. K plus 1 minus D. Ants is min, ants max 0 LO. D. Um, 5-2. If D K is not equal to M minus 1, K is less than M minus 1, right? If K is less than M minus 1, K is equal to M minus 1, then we're screwed. Why is it 0? 3, 1, 2. Why? Why did I do that? What? Why did I do that? Why did I type the +1? Scene to NMK, VL, pause N, scene to AI. K is less than N-1, ants is max, ants is min, ants, max 0, okay, +1 minus D. Ants is min, ants, max 0, LD. K is less than N-1. Yeah. Why did I type that? Okay. Flexible string. What in the world, man? Strange problem. What a strange problem. Why did I type x plus 1? Can anyone tell me why I typed x plus 1? String A and a string B, both the strings up like that. I also have a set Q. Initially, the set Q is empty. Choose an index I. Add AI to the set Q. Replace AI with C. Just in the zone, yeah. I don't know what the hell that was. Can you... Bro, okay. This is... Can you, like, not... Can you not... Not the guy in chat, by the way. I'm talking about this problem. this just like why? Just why, man? Why does this exist? Vector car vs sand st for cars. C s vs dot push back c get unique vs m is equal to vs dot size. VLOK 26 for J0, J is less than M, J plus plus. If I shift J and 1, OK, VS J minus A is equal to 1. For J0, J is less than T, J plus plus. J is less than N. If OK, Sj minus A, or Sj is equal to Tj, C is equal to 0. C plus equals plus plus R, else R is 0. I don't understand this contest. This is confusing. Oh, I didn't use K. I is less than or equal to K. Six, 3, 6, 6, 6, 11. God, scene to end to K, vector car vs, scene to S to T. So get all the characters of this. Well, M is vs dot size. Answer 0 for I is 0 up to 2 to the M. Built-in pop count I is less than or equal to K, VL OK. OK vs J minus A is 1. So if OK Sj minus A, yeah. Okay, okay. Okay. Like, cool, man. Given two binary strings. Index I is chosen uniformly at random. That's a decent amount of time. Okay, cool. Why did B take so long? Because I wrote x plus 1. Why the hell did I write x plus 1 in B? I don't understand. Okay, whatever. It's stupid, but okay. You're given two binary strings A and B of length n. Index I is chosen uniformly at random. The character AI will be flipped. Okay, so I don't understand. I don't understand, like, what the point of this contest is. So E of 0 is 0. E of 0 is 0. E of 1 is something plus E of 2. How does this work? I have to write out frickin'. E of 0 is 0. E of 1 is 1 over n times E of 0. E of 1 is 1 plus 1 over n plus n minus 1 over n times E of 2. Is equal to 1 plus n minus 1 over n times E of 2. So E of 2, 1 plus 2 over n times E of 1 plus n minus 2 over n times E of 3. One plus 2 over n times this plus this. So C into n vector PL B n PL curve is equal to 0, 0. So we need mod op. And we have 998 mod. I hate math. I hate math so much. I'm not gonna have fun with this. My mic is on mute, right? Yeah. Okay, so LLF is LLF is 1 minus 1 I times mn is minv n times minv m mod mod. I times minv n mod mod times cur.s mod mod. F is equal to minv f. C is equal to 1 plus I times mn mod mod times cur.f mod mod. D is equal to n minus I times mn. Cur is equal to CD, VI is equal to cur. So we end up with E of n is equal to 1 plus n over n times E of n minus 1. So you're actually fine. Then we are res n plus 1. Res 0, 0. Res n is equal to cur dot vn dot f. I is n minus 1. I is greater than 0. I minus minus. Res I is equal to vi dot f plus vi dot s times res I plus 1 mod mod. Okay. Okay. Yes. Sure. Okay. I mean, yeah, C into NST, LMN is minven. Vector POVM plus 1, PO cur is 0, 0. 1 minus I times min mod mod times cur dot S. Plus I times min mod mod times cur dot F. D is n minus I mod min times min mod mod. C is C plus F. D is D times F. CD. 1 minus I times min mod mod times cur dot S mod mod. F is F plus mod mod mod. Yeah. Okay. Sure. It's just a strange contest overall. I don't know why these problems exist. Recently a tree has fallen on Bob's head from the sky. Sure. Tree has fallen. Recently a tree has fallen on Bob's head from the sky. The tree has n nodes. Each node U of the tree has an integer number AU written on it. The tree has a fixed root. First Bob chooses some node R. Then Alice chooses a node V. Pick one or more nodes from the subtree of V. Score will be the bitwise XOR of all the values written on the nodes picked by him. Bob has to find the maximum score he can achieve for the given R and V. Are you serious? Bro, like, bro, come on, man. Seriously. 10 to the 9th. Recently, a tree has fallen on Bob's head from the sky. The tree has end nodes. Right. After that, Alice chooses the node V and tells him. So we want the basis of the subtree of V for a given R. Which means rerouting, right? So I mean, we need to get this. So we reroute, right? So then you're going to be everything except for this child. Okay, sure. I don't have a basis template. I guess that's fine. Struct basis. So ints lx if x and I and 1 if else I is equal to -1 void else I is equal to x, return x are equal else I. BL edge. Clear C and AI. For I 0, I less than -1, I plus plus. C into Q. V, C and R to V at R dot push back VI. Okay, so basis cur for LOX add V if X DFS 1 XV cur dot merge basis cur dot ints AV DPV is equal to cur. DPX dot else. Wait, how does this work? Push. R dot merge DP child I. T I is equal to R. Basis par, right? Basis cur is equal to DPV. Basis L is equal to par. L dot ints AV. For L I is 0, I is less than S, I plus plus. Do that later. For L I is 0, I is less than S, I plus plus. cur is dpv, L is par, L dot int AV. So basis CT is equal to L. If I plus 1 CT dot merge TI plus 1 L dot merge DP child I DPV DPV is what? Is equal to CT DP child I is equal to cur DP child I is equal to store DFS2XV DPV. Okay. Why? Bus error. Cool. Awesome. Yeah, child. What? Oh wait, child I. Why exactly? V is 0. Child is 0, 0. This is dumb. Okay, so it's a 0. 4LT is equal to B minus 1. If X and I is 1, if L's I is not equal to negative 1, X are equal to L's I. Return X. If check ants plus 2 to the t is less than 2 to the t, res I is equal to ants. dp x dot check. Cool. All right, you work. Might be slow. Scene to n for I 0 up to n. Agi.clear, add I.clear, scene to AI. I 0 up to n minus 1, scene to x to y, minus minus x, minus minus y. Adj dot pushback y, adj y dot pushback x. Scene to q, lrv, scene to rv. Yeah. Add r dot pushback vi. So adj.clear, at.clear, scene to AI. At r dot pushback vi. DFS1 is simple. Cur.merge dpx, cur.insav, dpv is cur. So for each query, dpx.check, ants plus 2 to the t is less than 2 to the t, ants plus equals that, res I is ants. VL child.pushback x, basis r dot merge dp child I. Ti is r. Basis cur is dpv. Basis L is par. L dot ints AV. So take the parent, put u in here. Basis ct is L. If I plus 1 is less than s, ct dot merge ti plus 1. Basis st is dp child I. Ct dot merge ti plus 1. Basis st is dp child I. dpv is ct. dp child I is cur. dfs2 child iv dpv. dp child I is st. dpv is cur. L dot merge dp child I. Okay. We're gonna test you. Don't need pragmas. We could use pragmas actually, but we'll see. AI is RNG mod 2 to 30. X is equal to RNG mod I plus 1. Y is equal to I plus 1. Okay. I didn't. What are you? 200,000? Yeah, that's fine. Yeah, that's fine. Do you make life easier? Sure. Okay, we'll do that. Alright. Alright, let's see. Don't get time limit exceeded on test 43, please. Good. Okay. Wrong answer on test 4. Wrong answer on test 4. AI is up to 10 to the 9th. Okay, great. L's I is -1. If x shift I and 1. If L's I is -1, L's I is x. Return. Yeah, okay, so basis is probably fine. We have some issue with c into n, agi.clear, add-i.clear. Res is going to be reset per query. That's fine. C into AI. For I is 0 up to n minus 1. C into x to y. Minus x minus y. C into q. I is 0. I is less than q. I plus plus. Well, rv. C into r to v. R dot pushback vi. I is 0 up to q. Print res I. So void DFS1, LOV, LOP. Basis cur for LOX adj v. So we can choose any things from the subtree. Basis cur for LOX adj v. If x is not equal to p, DFS1 xv, cur.merge dpx. Cur.ints av, dpv is cur. For auto xi add v, well, answer 0. For t is b minus 1. T is greater than or equal to 0, t minus minus. If dpx dot check ants plus 2 to the t is less than 2 to the t. So if we can make this, yeah.
if we can make this, right? We have something with this bit. We can make at least this. If we have something with this bit, then we can make at least this. VL child. For LLX, add v. If x is not equal to p, child.pushback x. S is child.size, basis r, vector basis ts. R.merge dp child I. Ti is r. Basis cur is dpv. Basis L is par. L.int av. So we have the entire parent. And now we're processing this. So for I is 0, I is less than s, I plus plus. L.int av. Basis ct is L. If I plus 1 is less than s, ct.merge ti plus 1. Basis st is dp child I. dpv is current. dp child I is cur. dfs2 child I v dpv. dp child I is st. dpv is cur. Basis cur is dpv. So I mean, this is going to be everything. This should not be dpv. This should be what? It should be ct. Yes. dfs2 child I v. You should not be dpv. Wait, should you be? No, you should be. Wait, that doesn't matter. ct. Okay, how does this work? Am I merging bases wrong? For each element in the new basis. Is this wrong? If x is not equal to -1, int x. Wait. Could this be a problem? I is 4, x is -1, 31. Now, okay. So like this is going to be problematic. For LLX b.Ls, if x is not equal to -1, int x. Okay, let's try this. I don't write bases often, and you can tell. Can you please load? You're in a rooted tree consisting of n vertices numbered from 1 to n. Vertex 1 is the root of the tree. Vertex 1 is the root of the tree. Each vertex is an integer value. Value of ith vertex is ai. Good. Okay, we're doing not bad. This is very not bad. So I need to solve f. You're given a rooted tree consisting of n vertices numbered from 1 to n. Vertex 1 is the root of the tree. Each vertex has an integer value. The value of ith vertex is ai. Do the following operation at most k times. Choose a vertex v that has not been chosen before. An integer x such that x is a common divisor of the values of all vertices of the subtree of v. X is a common divisor of the values of all vertices of the subtree of v. Multiply by x, the value of each vertex in the subtree of v. Well, that's strange. Okay. What is the maximum possible value of the root node 1 after at most k operations? Okay. So AI is less than or equal to 1,000 is a big deal. So in essence, you can take the GCD and square it with one operation. In essence, you can take the GCD and square it with one operation. There's no reason to not square it. So So 1,000 log 1,000. That's kind of big, right? 1,000 log 1,000. It's like 10,000. That's not that bad. So next n plus n minus 1 lines contains two integers ui and vi. It's guaranteed that the sum of n over all test cases. Ugh. So we do 12. So why is T 50,000? Could you like not? Could you not? Could you please not? So we pre-factorize, right?
this is fun. This is fun. So we do DPV is such that we make the GCD in the subtree this. And for each child, we can square U or we can not. $1,000 is tight, huh? So K doesn't really matter. So I mean, formally the transition is for each AI from 1 to 1,000, for each child, for each X from 1 to 1,000, such that X is a divisor of AI. That matters. X must be a divisor of AI. So for each divisor of AI, which is actually not that many, right? How many divisors? Highly composite. Give me this thing. Daria, thank you. 32. Okay. So for each divisor of AI, for each of the 32 divisors of AI, we're only interested in the numbers that have this, have these factors, right? We're only interested in the numbers that have these factors, or a subset of them. How many numbers can we make with 2, 3, and 5? Not that many, right? Not that many, right? 1,000, man. 1,000. That's really something. $1,000. So we can get rid of all this. We need to stare at some code. All right, we need to stare at some code and look at this. So we're gonna keep yellow. We're gonna keep yellow as int. We're keeping test cases. Trees and connected undirected graph. That cycle is a rooted tree is a tree. Yeah. So 840 prime factorization. Yeah, we can't really make that many numbers. Like 1000 is pretty. 2 times 3 times 5 times 7 times 11. 1000 is pretty damn small. Wait, hang on. We're only interested in subdivisors of x, right? Divisors or multiples. We're only interested in subdivisors of x, right? So divisors or multiples. So 2 times 2 times 2, 2 times 3 times 5 times 7. So we're going to number 3. Going to pre-compute some stuff. So gen primes 100. Constant max is 1000. 4i is 1. Let's go to max, I plus plus. VLF factors I. VL div. So div I is equal to get divs I. What? What's the issue? Okay, screw you, STL. Okay, VLG is equal to F, get unique G. Map. At G dot push back I. VL mask. Mask I is G. Do we need factors? Not really. M is mask I dot size. VLF. VLR. 4L K 0, K is less than M, K plus plus. J shift K and 1. R dot push back mask I K. 4 LX at R F dot push back X sub M I is equal to F. Div I dot size. $125. $840. How big is 840? 141. That could be problematic actually. Well, it's 3,000. 3,000 per node. That's fine. That's fine. Bool div p. 4 L I is 1 as let's go to max I plus plus. 4 L j is 1 j. Div p I j is equal to I times I mod j is equal to 0. Okay. C into n. Edge I dot clear. J is 0, j let's go to max, j plus plus, dp I j is k plus 1. Ants. One. If dp is 0, j is less than or equal to k, and it's equal to j. Okay, so for LX div v AV dpx is equal to 0. dpvx is 0. For LX adj v if x is not equal to p. Okay, so for LX div v AV for ly sub m AV if div p so if y times y mod x is equal to 0, c is min c dp x dpt y. Div s ij. Okay, so if div square yx if div p y x c is min c dp t y, yeah, dp vx is equal to min k plus 1 dp vx plus c. Cool. Why? Let's see. Okay, cool. C into k for I 0 up to n, agi.clear. dpij is k plus 1, c into ai. For I 0 up to n minus 1, c into x to y minus x minus y, adj. dfs, dp0j plus 1 is less than or equal to k, yes. Lx div v av, dp vx is 0. For LT adj v, if t is not equal to p, dfs tv. For Lx div v av, LC is k plus 1. For each y in submask of AV. Wait, hang on. Wait, no, that's not enough, is it? Is it? No, it's not. Huh. How much time do we have? 2 seconds. Submask is not enough. I just realized. That's fun. Okay, let's do this. Soup S. Okay, so we don't need this at all. We do need divs. Okay. For Lj is 1, j, let's go to max, j plus plus. If j mod I is equal to 0, soup p soup si dot push back j. Okay, so we don't need this at all. For Lx soup p px, c is min y soup sx. Okay, this still works. Okay. Now 1/1,000. How fast are you?
mean, you work. For LOI, sup px, c is min, c, dpty. C is min, c, dpty plus 1. dpvx is min, k plus 1. dpvx plus c. Okay, I believe. Work. Good. Cool. All right. I guess that's that, huh? Yeah, that was not bad. How do we do in general? Okay. I'll take that. Third in virtuals, second in official. Sure. That was not bad. Finally. Something is going not bad. That's good. I don't think we would have ever beaten Jangly on that. So that's pretty close to optimal. Frickin' Jangly, man. Why is he doing div 2s? Why am I doing div 2s? I don't know. Yesterday's F2. Was there a round yesterday? Oh, no, I have not. No, not from the stream yesterday. No, I have not figured that out. It's freaking impossible. It's 6:30 p.m. right now. How to get better at DP? Good question. How to get better at DP? How do you characterize that? Like, I mean, you can either like reverse engineer the pattern or like actually understand what you're doing. If you're doing the recursive formulation, like chances are you probably don't understand. I have a video on it. It's like not that bad. It's not the best, but it's a start for like understanding what you're actually doing with DP. And then once you understand that, then it's a game of recognizing states, recognizing transitions, recognizing how the parts of the problem factor into the DP formulation. And for that, you have to practice a lot. And make sure you understand, like deeply understand for every problem what DP is doing with that, like why that works, etc. Cool. So people solve that pretty quickly, I suppose. Well, that okay, that guy. Yeah, people solve that pretty quickly. I guess, I don't know, like you could do it pretty quick, I guess. Like you just kind of have to believe in the divisor thing and not get confused by the mask thing like it. I don't know why I did that. I don't know why I did the mask thing. It was weird. You just need to look at all the divisors of the number and then count. For each divisor, you look at for each divisor, you look at the multiples of it and hope that works. Apparently it does, so that's cool. Kind of feels weird that works. Like, kind of feels like it should be pretty bad complexity-wise, but actually it kind of feels like that's not intended, which might be the case. Which might almost definitely be the case, but whatever. So I did a bunch of weird things this contest. I wrote x plus 1 for b, which still confuses me, like why I did that. Like I just wrote x plus 1 here for no reason. And that cost me a couple minutes. And then what else happened? I don't know how to write basis.
All right, I need more experience with that. We need if x is not equal to -1 here. Otherwise, you insert some bad elements and it gets weird. Yeah, otherwise you insert some weird stuff. Which actually kind of no, no, it's gonna be bad. It'll screw you up. And then F got confused with the formulation. I guess that's fine though. It didn't take that long to fix. Probably could have found a better number than 840. I suppose there are other numbers that work, but whatever. It's fine. Why? Wait, what was that? Oh, I didn't even use like most of these. Yeah. Okay, whatever. Cool. Doing virtual is that good? Yeah. I mean, I don't do it because I don't like their problems. But if you are fine with that, and yeah, I mean, it'll help a decent amount with that, with getting better. Because it'll like, I mean, it's similar problem style. It's not like the exact same, but there's a lot of overlap between those two sites in particular, so it should help. Yeah. But I mean, if you're not out of Codeforces problems like I am, you should probably just do those instead because it'll be more direct towards what you need. Codeforces has like it's not like a consistent style, but it's like, it's more consistent than you'd expect. It's kind of weird. I don't know what to say about it. It's like it's weirdly not inconsistent. Like there's just a niceness to it that I very much enjoy. Maybe not div 2s. Div 2s are weird. Like some of these problems I just ask why they exist. But whatever. And not because they're like easy, just because there's just like nothing to do. Like you just like here you just like you okay, you're told there are almost 10 different characters. Okay, so just brute force what the set becomes. Like I don't know, man. What was this one? This one was fine. This one was weird, but fine. It's just like strange problem set. And then this one was just annoying. Like it's just blah, like probability task, whatever. Annoying. You just do the math and then it works. Works on samples. You submit it. Life is good. That's how it works. I don't know why they didn't ask for all of them. I guess part of the observation they want you to make is that the characters themselves don't matter. It's just the number of positions. Maybe there's a nicer way to do this, but I don't know. It's kind of I've always struggled with this like this back and forth thing. Specifically expected value. Like it's kind of unintuitive to me. I failed at Div 1D because of that. Because of like not being good at this idea. So we are third. That guy did not knock us out in the real standings. Cool. I'll be right back. I'm gonna get some water. What's the topic What's the topic I find most annoying? Math, probably. Because I'm not good at it. I'm not good at it, and it's like incredibly common. So it's not a good combo. Well, I'm like okay at math, but like I'm generally not gonna be able to solve like the harder math problems, but I can solve harder other things. The FSTA? The hell? Oh, he actually would have beaten me. Would he? I don't know. How do you wait? How? Actually, how do you FSTA? Like, what? Wait, I need to see this. How do you FSTA? Like, what did he do? L now is some LOA. LS is negative 100. Oh. Because n is up to 10 to the 5th, not 100. Okay, sure. Let's see. What are the difficulties? 2,500. Damn. I guess it kind of makes sense. It's like basis rerouting, kind of weird. That's 2,600. Sure. Alright, let's get back to real problems. So we just finished 601. This one I don't want to do. This one had to make one. That one's strange. It's gonna be hard to find another problem to do. Swipe or no swiping. This has no solves, right? Yeah. So like no. This one I remember H was cheesed, so I don't really want to do it. I remember like you could cheese it. That's why I skipped it before. Why is carrot not showing up? We'll try this one, I guess. There's a good chance we don't solve it, but try it for a while, I suppose. Why? Oh, this was unrated, right? Right. Okay. Alright, so remind me of my solution for E1. choose an integer and an n-squared integer is pij. It generates a random bipartite graph with two n vertices. There are n vertices on the left and n vertices on the right. Turns out that the tests will be strong only if a perfect matching exists in the generated graph. What is the probability that this will occur? Following n lines describe the probabilities of each edge appearing in the graph. Let me resolve E1, I guess. I remember it was some in the middle thing. And vertices on the left side. So what characterizes a perfect matching? So we split you into two halves. Split you into two halves. And we'll say that oh, right. And then what? What are we gonna do? Split you into two halves. Split the left into two halves. This is so strange that like the hard version of this problem has n1 bigger. That's crazy. Following n lines describe the probabilities of each edge appearing in the graph. Yes. So split you into two halves. For each mask, you find the probability. How long does this take? It's a second. Split into two halves. For each mask, we find the probability of split into two halves. For each mask of edges on the left, we're going to say for each mask of edges on the left, we're going to say you exist oh, right. We make masks for you. So 6 choose 3 is 20. Then you're going to be 2 to the 20. And 7 choose 4 is too big. Right, I remember this. We do SOSDP on the probabilities. Right, okay, yes. So that's obviously not going to work for E2 because 2 to the 35 is kind of big. Okay, we're gonna have fun with this. This problem. I muted the mic, right? Sanity check, yes. Okay, so go. 2 to the 21 edges on the left, 2 to the 21 on the right. This is where we're at. So, alright. We can't like fix the matching because let's do something. Right. Let's look into something. So there's exactly one place to optimize this. SI not equal to 0 plus count. What? Oh wait, where the hell is this being printed? Okay. So that would make sense. Aha. Okay, good to know. All right. Beautiful. Beautiful. So n is 7. Okay, so let's see how bad you are on the first side. Cried during sleep? What is that? Like during the dream, or like you woke up with like a wet face? What does that mean? Why am I? Okay, 128. Like, what does that mean? Vector VO edge, crying in dream, then also woke up crying. That's strange. I've never had that happen. I'm sorry, I don't know what to say. Usually my dreams are happy and blissful. 128. Using LO is long, right? Yeah. So, 1 LO. Set LO ST. T shift J and 1. PV add AJ.F. I guess I'm using her. Yeah. Built-in pop count R is 3. What is mark? Oh, we need to do this separately. Size. Okay, stop. You're not gonna do that to me, right? Okay. Make 0, 3. $2,822. Okay, that's good. 2 to the 21 times 128. Mask that push back I. It's better. It's not gonna work for the other half. Okay, we've got to measure this. I have to do some constant opt. How are you this bad? Oh, really? Damn. What? Oh, crap. Okay. I didn't give it input. Seg fault. What am I printing? What? Oh. Oh my god, okay. Alright, I've got to be smarter about this. When does seg fault happen? I don't know. Like this was an out of bounds access. Because this should have been 4 and not 7.
So we can be smart about this, right? And we look into so we do 2 to the 28th. The problem is the set could be enormous. And I have no idea if it will be. How big is the set operation? Let's look at that. Oh, holy Christ. Okay. Really? 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 Damn, I need to I need to remember how this works. Okay, VLPS. If T mod 2 to the 20 is 0, get unique PS. Right. T. Why didn't it work? Type. Oh, tote. What? Why? Okay, that makes no sense.
Okay, so you're at the 2 to the 28th. Point is 0. For k is 0 up to 7. This is 2 to the 18th. 2 to the 18th times 35 times 34. No. I guess that's pretty bad. Okay, this is gonna take forever. I can't tell if you're gonna be better or not.
So this is gonna run for like an hour. Yeah. So that's fun. Alright, we might as well start rewriting you, right? Okay, so come on, man. Also, if m is 0, you're useless, right? So you need to not be a set. That's the main thing. All right. Okay, so void p. Bro, you gotta chill. You gotta chill, man. 2 to the 26. Okay, we have a new power of 2. Wait, why are you 168? Something's clearly wrong here. Tote.pushback m. Vector VOPS, VOV size, VO mask, L point is 0. For I is 0 up to 2 to the n. Built-in pop count I is size. Mark I is point plus plus. Mask dot pushback I. Oh, wait. Well, that's sad. Why did we do this? If MT pauses 1, break. Wait, why did we do this? For LR mask. Alright, because we need to match you with you. Right. Okay. Well, we can't exactly do that. Oh, yeah, we can. Okay, if built-in pop count I is 3.
God damn it. Built-in pop count I is 3. Mark I is point plus plus. Alright, well that makes a lot more sense. So I was wrong the whole time. That's cool. Alright, well, okay, so what we need to do is return. So there are 35 masks. Okay, well that's better. The prog 3516. Okay, it's not gonna make that much of a difference, right? So size equal to r minus l plus 1. 4 Okay, I mean, if you're both size 20,000, then that's fine. So we just need to do this efficiently, right? So size is r minus l plus 1. For I is 0, I is less than 2 to the size, I plus plus. VL M at so for I is 0 up to 2 to the size, I plus plus. If I shift j and 1, PR is equal to PR times PV TP. Okay. I shift j and 1, PR is PR times PV TP mod mod. Otherwise, yeah. edge t p is equal to 1. For I0 is 35 plus plus. Pos ij is equal to t plus plus. Are you gonna work? You're not gonna work, are you? You're gonna be very confusing. For I is 0 up to 35, t is 0. For j is 0 up to n, if I ship j and 1, pos ij is t plus plus. What is Matt? BL at so for LM at P, actually, we don't really care. I don't really need pause. We'll keep it for now, but I don't really need it. Are you seriously? Okay, that's not correct. That's not correct. Something's wrong. Something is very wrong here. VLPPS. If L is equal to 3, E is equal to R XOR 128. I should have printed tote. Whatever. We'll do it next time. By the time there is a next time, we'll have finished the FASTA version. So for LLM at P, for LOJ is 0. T is L plus J. If edge T P No, we do need pause. For I 0 up to 16. So this is wrong. Okay. Well, T is L plus J. For x is 0, x less than 2 to the size. X is less than 2 to the size, x plus plus. If PCX is equal to pause R is equal to pause rev m p. If PCX is equal to R, for Lj is 0, j is less than size, j plus plus, Lt is equal to L plus j. If adj T P pause rev m pause m x or 2 to the j is equal to 1. Your prog. PCX is R and prog mx. Prog save. Okay. DFS P plus 1 prob times PR mod mod. For Li 0, I less than 35, I plus plus. If prog I 15 m plus equals so we don't need any of this anymore. DFS 0, 1. Cool. Prog I 0 is equal to 1. Why do you not work? Okay. Alright, so we need you. Point is 0. we don't have to worry about this for now, but. Wait, what are we doing? Oh. Oh. Two to the, okay, something is clearly wrong here. How big are you gonna go? What? I is 0, I is less than 2 to the size, I plus plus. PR. L is 0, R is 2. R minus L plus 1. J is 0, J is less than size, J plus plus. L of T is L plus J. If I shift J and 1, PR is PR times, yeah, okay, sure, it doesn't matter. DFS P plus 1, prob times PR mod mod. What in the world? How big is this going to get? Oh, wait. Oh. Count is 0. Toad dot clear. Okay. Well, something's wrong there. And you're too slow. I'm at P. raised rev m. OR is pos MP. Oh, wait. That's why. Okay. So you are much faster, but nowhere near fast enough. 25958. Okay, I mean, that makes more sense. So how fast is this going to be? So we're at 2 to the 28th here, which is already like pretty big. And we have this factor of this. Like 2 to the 28th. Okay, so you're still taking way too long, obviously. So for I0 up to 35, I++, for LOX, mat pos IP plus 1.
Okay, so you don't get that big. Which means that once we do this, this will work. Int. Long. Okay, so int. You should be alone. So 2 million.
Yeah. So even you're very big. How far do you make it in 15 seconds? Not even close. Okay. So we need something better. Why are you so slow? I don't actually know why you're so slow. So you get through 8 million. Okay, this isn't gonna work. Let's do something more scuffed, right? So we can do like, okay, I mean 2 to the 21 is gonna work. This is fine. 2 to the 21 is gonna work. So then we, we could do 40,000 squared. That's okay. Okay, I have a plan. We're going to run you on this and this. Okay, so vector PL SLSR. Tote.pushback mprob. Sort tote.begin, tote.end. Vector PL and tote. Auto VP is equal to tote 0. If V is equal to NV, P we innovate. Okay, PR. Good. Okay. So that's like most of the work. Let's make you 16. Let's see how much faster you are, right? Significantly faster. Okay. Now it's about the same. All right, sure. Okay. So this isn't the problem. Does this make you faster? Pragmas. Yeah, it does. Okay, cool. All right. So now, for each of you, we decompose you into your masks relative to 1. So is this fast enough? This is kind of a pain. So you're really 25,000. And we do get 15 seconds. But like, ugh, you know? Like, ugh. So. Yeah, it's not very helpful. Okay, so we
We don't get a memory buff. Oh wait, we can be very smart about this. Okay, we can be very, very smart about this. Okay, so we can actually do this in 25k squared, and this is gonna work. Awesome. Okay, good. So, how does this work? Sorry, I've been neglecting chat again. I've been thinking about this problem. How is chat doing? Did I stop? No, I'm good. Sorry, I didn't do that yesterday because I was because I was sad that I didn't get anything. But I'm gonna do it again today, and I'll add yesterday's too. That was psychological damage. That's what it was. It wasn't a. It's not a. I'm gonna keep updating it. Sorry about that. I just I didn't I don't know, man. I didn't want to do that. That hurt. Stupid. All right. Okay, we are yeah, I'll do that tonight. Okay, so okay, so all right, so okay, so we have you. Vector vector array LL8 NR 4 auto X P SR array LL8 B 0 is equal to P 4 LI 0 4 J 0 J is less than 35 J plus plus if MT S is 0 if MTJ shift I and 1 continue
PR is equal to MTJ XOR 2 to the n minus 1 minus 2 to the I. If M shift J and 1, S plus equals 2 to the rev R, V I plus 1 is equal to S, NR dot push back V. Okay, now vector VLTR 128 VL 4 LI 0 I is less than 7 I plus plus. Now VLPR 128 4 LI 0 I less than 2 to the n I plus plus. We're being very inconsistent with 128 and 2 to the n, but whatever. LP is 1, 4, LJ is 0, and J plus plus. If I shift J and 1, P is equal to P times, what are you? PV n minus 6 J mod mod. Else P is equal to P times 1 minus PV 6J plus mod mod mod. Okay. PR. Do I already have you? No. Why are you crying? Oh. I don't know. PS. I is P. Okay. Now, for TRI. Wait, what is this? Oh wait. VLTR 128. TRI is equal to TRI plus PSJ mod mod. Okay. SL. So we're going to do the same thing here. For Li 0, I is less than 7. Plus equals 2 to the J. Okay. For auto X NR MK is 0. For Li 0, I is less than 7, I plus plus. MK plus equals VI plus 1 and XI plus 1 is greater than 0. Shift I. Ants is equal to ants plus P times X0 mod mod times TRMK mod mod. Okay. Alright. You're going to give me a number. Okay. You're going to give me a number. You're gonna give me a correct number? Nice. Okay. Let's run you. And then run my E1. And if you work, then this is probably fine. Yeah, okay, sure. All right, you're gonna be fine. Let's go. So you're gonna take a solid 5 seconds on every test, which means if you make it past test 1, you're gonna work, right? If it makes it past test 1, it's gonna work. Good. Okay, now it's gonna take forever. As long as it doesn't wrong answer on some n=7 case, then it's fine. It's going to take forever. Okay, good. So you're probably fine. I believe. I believe. I believe. Beautiful. Okay, it has the same runtime on every case, so it's not going to TLE, unless it's right on the edge. Let's just watch it. What a beauty. Ah, what a beauty this site is. 10 seconds. A 10-second runtime. That's crazy. 3200. Be that way. A 10-second runtime. What a wild problem. Yeah, okay. Damn, I've never had a 10-second runtime before, I think. Like, that's actually new. That's crazy, man. What? Okay, sure. Okay. All right. I don't know. That's that was a problem. That was indeed a problem. And then F is impossible, right? Yeah. That was indeed a problem. Is F at any solves? Got one attempt by Hector Walla of all people. No solves. Okay, cool. Why are you 32? Oh, because a master solved you. Ah, I hate that, man. I hate that so much. That's so annoying. You can get top 10 without E. Bro, that's wild. Wait, I could have sworn you solved E2. Okay, I guess not. So everyone who solved E1 solved E2? Or did people solve E2 and not submit E1? $200 milliseconds? Are you serious? Neil. Bro, wait. Execution. Are you serious? There are people who did this in 100 milliseconds. 100 milliseconds. That's crazy. That's crazy. That's crazy talk. That's crazy. That's insane. So we got E1, we got E2. Cool. How does this work? Right. Okay. What was this one? Right, and then G is impossible. Yes. So we're not doing it. This one, we've mind solved G2. I remember that. It was lame. This one we did. So now we have a problem, because now we're gonna start like either you're gonna be impossible or number of pairs. Beauty of the permutation 1, 2, 5, 3, 4. This is the count pairs round, right? Ah, the count pairs round. The freaking count pairs round. Oh no, it's not. Okay. It's not. It's not the count pairs round. This one we've looked at. How hard are you? I mean, I've solved you, but how hard are you? 29. Okay, whatever. You, I'm not doing. Yeah. Yeah, we're gonna have a problem soon. We're gonna be out of problems. I mean, I know how to do E. It's geometry. I don't need practice coding. I need practice thinking. How hard are you? Ugh. And Rainbow solved you, right? Yeah, so you're gonna be... What in the world? Oh, this is the count pairs round, right? I mean, C wasn't that bad. D was kind of weird. Should I look at this? We can look at this. Got 3 solves. Okay, fine. We'll do it. Moscow Workshops ICPC team gets a balloon for each problem they solve first. So many balloons that they didn't know how to... Why do problems have big TL instead of reducing max input? Probably for blocking out unintended. Because if you double n, then n squared goes up by 4, and n log goes up by 2 point something. And if you double the time limit, then that works better. Although, I mean, for this problem, like you literally could not, like n is 7, you know? Like there is no variance in n. If you make n 8, the problem is unsolvable. Or not unsolvable, but very, 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 very different. Very much harder if you make n 8. If you make n 6, then you get the easy version. Okay, well, look at this one. Moscow Workshops ICPC team gets a balloon for each problem they solve first. There are several balloons. Each one is colored and one of K colors. Choose K-1 balloons such that they are of K-1 different colors and recolor them all into the remaining color. Right. Perform this operation any finite number of times. Right. So, I mean, one operation is subtracting 1 from all and then adding n, but not necessarily. And that no number can become 0 after that thing. If we do an operation on every element, then we might as well have not done any. So we're counting reachable operation counts, pretty much. Given that, oh yeah, that too. I thought the checker has a constant time limit. Well, I'm not sure. I thought it was always 2 seconds, but I have no source for the information, so no idea. Something's going on here. Okay, so stuff. Okay, so there's going to be some element we don't do an operation on. That means the total number of operations is at most the max element. If stuff is big enough, I feel like we can always do the operations, right? Let's suppose like okay, suppose all elements are at least n, right? Then, yeah, if all elements are at least n, then we're guaranteed to win. Okay, so we're gonna write a brute force because we always do that. Because I wanna check some claims. Holy Christ, this code is long. So we're gonna write a brute force. You are 998 mod. Okay. Okay. So C and N via A N for LOX DFS A set via ST. If st.count A return st.insert A. AJ minus minus is equal to 0, pos is equal to 0. RJ minus minus RI plus equals N minus 1. If pos DFS R. Stop. PRST. Every element is at least n minus 1. Right, then we can reach pretty much anything. 1 is less. If x is less than 0, x plus equals n. Mod up. We need mod up. For LOXA minus minus x, if x is less than 0, x plus equals n. So what are you? So your ST, so we have this many operations. We have n numbers that sum to ST. So we have ST and n dividers. ST plus n minus 1, n minus 1. Mod. If ST is greater than or equal to n, and is equal to ants plus nck, ST minus 1, n minus 1, mod. Stop it. Okay, why? PRI ants. That's why. Not VST is 1. Okay, I mean, this isn't gonna work, but T is 0 up to n. You're gonna still overcount, right? That makes it worse. I mean, obviously that's not gonna work. Okay, so no, wait, why not? Actually, why not? Wait, why does that make the answer bigger? CT is N. So I is 1, Nance is 4. What? Oh, that's why. Q via Q dot push pair via LO. A0. While not Q dot empty, auto. Q dot pop. Q dot push R D plus 1. Okay. Okay, so you should not be, you should be 4. You should be 10. You should be, why are you wrong? PRACT. Oh, minus ST, that's why. Okay, good. So, 7. Okay. Sure, so this will work, except for this, right? Actually, will this just work? Okay, sure. AI at AI mod and pushback I. LT at I minus 1 mod n. If AT is less than I, okay. If run. Oh, wait, okay. If that's why. Because it's old code. If not run. Why? If local. Wait, what? Oh. Okay. Said 10 to the 5th. Okay, this seems fine. It's actually gonna work. This feels like it can't work. This feels like it cannot work. Okay. 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 Sure, man. Sure. Sure. Okay. I, I don't know what happened. That was okay. That was correct. Okay. That was the solution. Sure. I'll take it, man. I'll take it. What in the world? You just do it. You just do it. Okay. Okay, man. Okay. 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 Strange. Okay. Yeah. Sure. You just do it. I, I don't know what to say for that. That just worked. Like that just worked. That just worked. It just worked. It just worked. I mean, where's their big test? 90,000. Yeah, I mean, if n is big, like the answer is small. I'm just, okay, man, okay. I, I guess that works. That's kind of crazy. Like you just just iterate over the number of operations, and you find which ones need to be operated on, and then you subtract out the cases where you do operations on every element at least once. And that's it, I guess. LT at, yeah. Okay. Okay, cool. Cool problem. Cool. Very cool. I'll take it. I will take it. I will take that. I'll take that with stride, with pride. Okay, we're gonna get my old template back, because now I'm confused. I want you. 3,330 minutes. Sure. Sure, man. Okay. We're gonna make, oh, it goes long. I don't know what happened there. If you're wondering what happened there, I have no idea. If you want me to explain my solution, I have no idea. Oh, that's crazy. That's crazy, bro. Okay. I don't, like, 2 hours on this, 30 minutes on this. And what? And it just works. It just works. It just works. Like, that just works. It just works. That's crazy that it just works, man. It just works. Like, it actually just works. I'm so annoying. Okay. Yeah, cool. This one, right. Okay. So what's up with this one? E is annoying as hell, and it's only 3,200, so I don't really want to do it. I remember that. You are this one. I've mind solved F. We've done G here. Yeah, we're really gonna start having a problem. We've looked at this. It feels like, I think it got solved because it's well known. Should we try this one again? I remember it was so weird. Man. It was so weird. And I could not figure out how to do this. Maybe we'll do it for the rest of the night, I guess. That'll be our fate. Should we do this? Yeah, screw it. Let's do it. Let's look at it. Again, I've looked at this not before on stream, but I've looked at it like before. and it was weird.
Bro, 30 minutes. That's crazy. Okay, yeah. Yeah, that happened. That just happened. Like it just worked. It was just correct. It it just worked.
That's wild. All right, so I know this one's 3400, and I know it's probably impossible. Not because it's 3400, but just because the fact that it's weird. And it got like, what, 2 solves, right? I mean, I solved F, which is 3500. So that doesn't, like, yeah, you got, E got 2 solves, F got 1 solve. And because of that, no, wait, you're a virtual. Yeah, F got 1 solve, E got 2 solves. So because of that, E is 3400, and F is 3500, and that's how Mafia works. That's cool. Yeah. Okay. Like bro. All right. We'll do it. We'll do it. Where were we? This one, right? Why does F have so many more solves? Is it because E is so weird? DP math 3500. Yeah. Okay, whatever. We'll look at F. We'll look at E. Right. So it's an interactive problem. Vasya enjoys solving quizzes. He found a strange device and wants to know how it works. This device encrypted with a tree with n vertices numbered with integers from 1 to n. To solve this quiz, you should guess this tree. Fortunately, this device can make one operation, using which you should guess the cipher. You can give the device an array of non-negative integers. On the device, there are n lamps. The ith of them is connected with the ith vertex of the tree. For all I, the light will turn on the ith lamp if there exists such vertex of the tree with number j, such that dist ij is less than or equal to dj. The light will turn on the ith lamp if there exists such vertex of the tree with number j, such that you're at most dj distance from it. Right. You have 80 operations and is 1000. And I could not make any progress on this before. I mean, you can do it in linear, obviously. You can you can query each vertex once, but I don't know, man. I don't know. It's kind of weird. It's kind of weird. 80. Like, that's rough, man. So I mean, if we query an index at the depth 1, right? Then we get all of its neighbors. If we query with depth 2, we get anything of depth 1 away, right? If the tree has a small diameter, then you can characterize the whole tree this way. Then what? So, I mean, there's no special properties about this tree. This device can make one operation in which you should guess the cipher. Yes, I mean, we can characterize the tree. We can split you up into
it is an interactive problem. So if the diameter is small, we can do some log shenanigans. We can do some log shenanigans. Diameter, we can do it in like diameter log n. I'm trying to remember the ideas I had for this. We can do it in diameter log n. I didn't feel hopeless on this. I just I didn't want to do it anymore. That's sort of why I gave up. But something. We're probably not going to solve this tonight, by the way. For anyone who will watch this back later, we probably don't end up solving this. See if we make any non-zero progress. If so, I might continue it tomorrow. We'll see. This is weird though. It's like I don't have enough time to finish this problem. But I will try it. Strange device. On the device, there are n lamps. Ith of them is connected with ith vertex of the tree. So we can pick some vertex Can we find the centroid of the tree? Wait, that's kind of... Wait, oh. Okay, suppose we pick the centroid at random. Like, suppose vertex 1 is the centroid, right? Then, does that even help us? Because then we can get all of your neighbors. We can get all the neighbors of your neighbors. But what does that accomplish? Even if we like know the centroid by magic, like what does that do for us? We need to guess the tree. So we need to find the set of neighbors for each node. We need its list of neighbors. That's what we need. We have this arbitrary limit 80 imposed on us by the problem, which is 8 log n. It's not enough for log squared. It's not enough for like root n or anything like that. Obviously, we can do it in n. We can do it in n queries, n-1 queries, which doesn't really help. I mean, our best hope is to partition the tree somehow. Somehow we partition the tree. Into k parts. If we can partition the tree into k parts, and then ask such that queries stay within those parts, then we'll be fine. If we can partition the tree into k parts, and then ask in parallel on those parts. Okay, but we can't even necessarily do that. Because like you could have a star graph and then you just cannot do that.
D was construct, right? It wasn't count? Yeah, it was construct. Just thinking about that. Elsie enjoys sewing quills. He found a strange device and wants to know how it works. Let's define dist ij as the distance between vertices I and j in tree, or number of edges on the simple path between vertices I and j. Can't like do random stuff. How do you come up with a problem like this? What the hell? I mean, I guess you have to do like solution to problem for something like this, but what in the world, man? This is so strange. It's just a strange world to exist in, this problem. It's just strange interactions, strange thing. Tree one integer and the number of vertices of the tree which encrypts the device. So now you show string s with length n. I mean, like, there are a lot of trees. We have a lot of bits to use. Like, we have to use a lot of bits. We have a lot of bits to use. So... what does this accomplish? What do you accomplish? Ith of them is connected with ith vertex of the tree. For all I, the light will turn on the ith lamp.
feels like we have to partition the tree. Because it's the only way we get info about multiple vertices is if we know that some sets are disjoint. That sound in the background is my hair, by the way. just realized that my solution for the last problem didn't even need the sum constraint, right? Like, all it needed was the max constraint. That's actually kind of crazy. Huh. Interesting. Yeah, it's just 10 to the 6th. Like, it's just O of max. N doesn't even matter. I mean, max plus n log n, I guess, but whatever. What's up? Blah. This problem is up. This problem is weird. I don't know what's going on with it. And we have to partition the tree. Like, that's just what we have to do. If we
we don't partition the tree, then there's no other way to tell. And we fixed some vertex. Do we do something with the diameter? I don't know, man. This problem is up in the clouds. Its difficulty is up in the clouds. This one's 34, I think. It's one that I've tried before and have no idea on. Yeah, the older they get, the easier they get. I don't have a direct translation. This problem is weird enough that it might still be 3400, but I don't know. I don't know what it would be. The F is 3500. It would definitely not be recently. It would definitely be easier. F might just be unsolved because E was so weird and everyone got stuck on it or something. Well, I got one solved, but you know. I can find a diameter node, right? Like, as if that does something. I mean, we can't like split on the diameter, because it's weird. I'm literally just going down the contest list and looking at what I haven't solved. So it's from newer to older. Like I'm solving every problem in the range 3,000 to 3,300 from every contest, pretty much. That's the intent. Although we might have missed some from the recent contests, so I might look at that again later. Yeah, anything like that would work. Okay. If we split on the diameter, what does it do for us? Like, what does that do for us? I have no idea. And we can't really split on the diameter. We can get a bunch of nodes that are kind of close, but it's not going to give us a subtree. All we can do is something. All we can do is find the node, what? need to find the node. Boundary doesn't help us in the slightest. So I can pick some K, right? Pick some node, pick some K. Ask for all the nodes of distance K. It doesn't give us a partition, because some nodes can be of the same side. Pretty much for any strategy I could have thought of, there's always a badly behaving tree that degenerates it to N. There are just so many trees. Like, it's just, I don't know. Is there another strategy other than partitioning? Is partitioning the only thing we can do? Okay. Guess my hair is no longer a mess, so that's something. Unfortunately, this problem is still a mess. And no idea what's going on. No idea what's going on. So how does one partition a tree? If we can pick some node. Actually, wait. Pick some node. Okay. Now pick some of its edges at random. Wait. Something is happening. Pick some node. Pick a node at random, let's say. Pick a node at random. Pick some of its subtrees at random. Like, pick a random node and then pick some of its subtrees at random. Like, randomly partition its subtrees into two groups. Then query all the things at depth 2. Query all the things at depth 4. That's root n. That doesn't work. How does this work? Wait. Query all the things that we know are at depth 2. That gives us stuff that's depth greater than or equal to 4. Yeah, but like, what does this do for us? Then what? Then we have some stuff. I love Codeforces English, man. I find this so funny. I don't know why. It's just, I love the English stuff. Okay, I mean, that doesn't help us, right? Like, we need to... Wait, that doesn't work at all. Wait, that doesn't work in the slightest. Okay, yeah, that doesn't help. That doesn't help at all. If we could have somehow... Okay, would this have even helped? If we could somehow partition the tree, right? But then, like, given a star, right? We're gonna pick a leaf with high probability.
And if we pick a leaf with high probability, then all our partition is going to do is nothing. It's going to do literally nothing. So that wouldn't work. If we could find the centroid, if we could find the centroid of the tree, how would we find the centroid? Ow. We could find the center, which is how good is finding the center? Because we're doing distances. We don't have anything about weights. If we find the center of the tree, right, then we could still have the star case. If we find the center of the tree, does it cut the diameter in half? It doesn't, right? Nah, it does not. That's not how that works. It doesn't cut. It's not guaranteed to cut anything in half. It is a table of pairwise distances between vertices in this tree. Even if we could do that partition, like, does it actually help us? It's like it wouldn't work in the star case, and the strategy to partition doesn't even work in the general case, and I don't even know how we would do it. That's what this problem feels like, man. Every strategy just dies. Just dies so quickly and so brutally. My God. That's what this problem is like, man. What is this problem like? This problem is brutal.
stuff. That's good. That's ISAF. Right, okay, yeah, sure. Did we look at this one? Why did we look at this one? That's this round. I remember this round, kind of. I remember the cat party. Oh my god, F has one solve. F has one solve in the entire contest. One solve. And now it has 700. What? Okay. Encrypt the device on the first test. How do we recover a tree? I mean, if we have a partition, if we can partition the tree, then it helps. We could partition the tree into just like 20 segments, right? We can get the whole thing in not that many. But we can't necessarily partition the tree well. And we can't even like, no, it doesn't work. I mean, can we just like, no. No, we can't. No, we cannot. To help to root the tree? I mean, we don't even... And suppose the tree is rooted at 1, right? Like, how does that help us? It doesn't really, right? It does not help us. Doesn't really help us. I mean, I hope the sink of the tree is rooted, but I don't know how it would actually help us to... I don't know how that would help us. this problem is going anywhere. Let's solve that f from this div too. I'm kind of curious about why I have one solve. Save copy Poland. Okay, they're end towns. So there's a graph. Taxi industry. Decided to introduce a new fee model for his taxi brand with a fee for each ride. It's not based on the trip length, but on the sum of the prices. Oh, that's why it has so many solves. That's why it has so many solves. I see. So the decreases are not interesting. The increases are what's hard. Lowest fee she must pay to travel for each town. Town 1, town N. Coroni. Yeah. The index of the road and its new price. So how do we do the increases, right? So I mean, we consider the shortest path tree. Well, shortest path, dag, I suppose. It's not really a tree. So I mean, find any shortest path, right? No, but what kind of time limit do we have? Okay. The price for each of the M roads has been decided. Yeah. So I mean, we need to find for each edge the shortest path without that edge. Like, we need to find that. We could be asked that. We could very well be asked that. We just remove that edge. I keep being motivated. Depends on, well, for me, it's that I can't live without it. That it's sort of like an addiction, and therefore I can't imagine myself stopping. For others, where it's more sane, I have a video on that, but mostly it's identifying the source and then drawing out, like identifying the root source of motivation and then convincing your brain that it matters, I suppose. Okay, so we have to find for each road the shortest path without that edge. Like, we have to find that. We have to find that. We have to find for each edge the shortest path without that edge. Well, almost. 10 to the 9th. 10 to the 9th is big. Like, we kind of can't really exploit that, can we? We have to find the shortest path without this edge. Like, we have to. How do we do that?
Shortest path without this edge. It's not like dynamic edge deletions. It's just each edge. So you consider like the shortest path tree going out from this node. So if you disconnect 1 and n, then obviously, if you're a bridge, then obviously it's a special case. If you don't disconnect 1 and n, we have some alternate paths. So we consider the shortest path tree out from this node, right? Consider the shortest path tree, right? Consider the shortest path tree out from 1. So if this edge blocks 1 and n, if this edge doesn't block 1 and n, then we have a path without it, so that's fine. This edge does block 1 and n, right? This edge blocks 1 and n in both trees. Does this work? This feels weird. This feels weird, but it feels like it works. So consider the shortest path tree. Consider any shortest path tree, starting from 1. If this tree is not a parent of n, if this edge is not a parent of n, then we just ignore you. This edge is not a parent of n, then we just ignore you. Otherwise, we know that we can reach anything okay, so how does this work? So find the shortest path. Considering any shortest path tree. Can we claim that anything in this subtree wouldn't have a path through n? Suppose that for something in this subtree, it's better to go around and through N than actually use that path. Suppose it's better to go around and through N than actually use that path. Like, what does that mean? What would that mean? Suppose it's better to go around and through this edge. And for us to take this path. It's like you have some LCA in the second shortest path tree. Suppose it's better to go around than through this path. Suppose it's strictly better to go around and through N than through this path. Let's say this edge as weight 1, right? We say this edge as weight 1. Like, I mean, the idea would be that it's strictly better to go around than through this edge. Like, this edge has weight 1, let's say. Then this edge has weight 100. This edge has weight 2, and this edge has weight 2. And this edge has weight 2, right? Then you're better. This feels true. This feels true, which is scary. Suppose this edge is, suppose it's better to go around. The shortest path for this goes through this. And it's better than any path that could come out of this edge. The shortest path for this must go around, must leave this component and then go down through this edge rather than stay here. So we have this edge of weight 1, right? what have you. We have this path that goes around. What I would claim is that this is a contradiction, right? So if this path is shorter than this path, then since if this path is shorter than this path, if this path is shorter than this path has length k, this path has length like k plus 1, right? It's like 100 and 101. Then taking this path has length less than or equal to 100 versus taking the path through this edge, which what? We're fixing this node. We're getting rid of the intersection. So we're saying that this path has length strictly greater than this path. And that this node is on the way of a shortest path. There's no path of length smaller, right? I don't know. I don't know how to prove this. This is kind of hard. If there's no path of length smaller, if there's no path of length, if there's no path of length smaller than this, I mean, you could be gated by this, right? But we're ignoring the intersection. We're ignoring the intersection of these paths. We're saying you must go this way, and then you must go this way, and then maybe we have some extra branching, but we're going to ignore this intersection. We're saying that you have this length. There's no shorter path to this node. then that means that this path has length shorter than this path. Right, and if there were such a path that went like this, right, we're claiming that this will be shorter than this. If we're claiming that this is shorter than every possible path that goes to here, claiming that this path dominates every other possible path that goes here, then this path dominates every possible path that goes here and then goes down. Which means that this path around, right? That's what we're saying, right? We're saying that this path is shorter than any path that goes here and then goes down. This path is shorter than any path that goes here and then goes down. That's true. That's a tighter condition, right? This path is shorter than this, which means it's shorter than this as well. Which means even if this repeats edges, this would still be shorter. It's just shorter than any path that goes here. If that's true, yeah, this is shorter than any path that does this and then goes here, by definition. Does it say that? It says that you're shorter than any path that goes here. I mean, this is a tighter condition, saying that you're shorter than something that does this and then this. Saying that you're shorter than any path that goes here. We could stress test this. This is a property that can be stress tested. But like, why? So like, you're shorter, we're saying you're shorter than any path that goes here. You're shorter than any path that goes here. This path is longer. You're shorter than this path, which means you're also shorter than this path. Which means that this path is shorter than this path. Which means that, okay. Yeah, okay. Okay, I can see it. So then we do small to large. Okay. Right. I hope, right? This path to here is shorter than this path to here, which by extension means that it's shorter than any path that goes up here and then down here, because this is strictly longer. This could just repeat edges, which means that you're shorter than any path that goes up to this node and then does this. Which means that the optimal path goes around this node. There's no better way to come from this node. Because if there was, then this path might not be shorter than it, right? Like suppose this was in fact shorter, right? If this is 5 and this is 6, then this would be better. If this is 7, if this is 5 and this is 6, then this would clearly be better. But if this is 7, then this would not necessarily be better. So like, shorter distance implies better. So not better implies not shorter distance. Yeah, so that would be a contradiction. Okay, so this is solved. Okay, cool. Let's see the difficulty. 3,000. 3,000 from a div 2. That's kind of crazy. That's kind of crazy. Okay, yeah, but that works. Okay. So the shortest path from here to anything in here does not go through this edge. Because again, if it did, then the shortest path to here, this would not be the shortest path tree. We'd have a different shortest path tree. The shortest path would be smaller. This would be a contradiction. But this feels weird. Wait, God. It feels a little bit weird. Oh, no, all we're doing is saying that this can't go through this edge. Because if it did go through this edge, then the path around this edge must be well, we didn't actually use. Yeah, we did. Yeah, we did. We said there's no shorter path around from here. So then if there is a path that uses this edge, then no shorter path around would be broken. That assumption would be broken. Yes, okay, sure. All right, cool. I guess we're done. All right. We'll call that solved. Mine's solved. I'm not going to code it, but we'll call it solved. Cool. I'm going to go. Discord as always, if you want to get notifications. Okay, bye.